Today, we delve deep into one of the most fascinating intersections of alchemy and early modern chemistry, the discovery of phosphorus by Hennig Brand. In an age dominated by mysticism, esoteric experiments, and fervent quests for magical transformations, Brand's accidental isolation of phosphorus represents not only an intriguing breakthrough, but also a profound pivot in chemical science. This account is not merely a recounting of history, but a rigorous, technical deep dive into the experimental challenges, chemical principles, and serendipitous results that defined one of the most significant discoveries of the 17th century. During a time when alchemists labored in shadowy laboratories seeking the philosopher's stone, the fabled substance capable of transmuting base metals into gold, Brand's methodical yet unconventional approach allowed him to capture a substance that glows with an ethereal luminescence. His meticulous experiments with human excreta, specifically urine, and the exhaustive analysis of its constituents illuminated a hidden world of chemical reactions governed by high-temperature processes and carbon-driven reductions. This narrative explores not only the historical context of Brand's work, but also dissects the chemical mechanisms underlying his unexpected discovery, thereby offering expert-level insights into his innovative protocol. Prepare to engage with a detailed exploration backed by quantitative analyses and technical evaluations, suitable for those well-versed in chemical sciences. We will examine the stoichiometry of the process, the energy dynamics involved in the redox reactions, and the subsequent evolution of phosphorus as both a chemical curiosity and an industrial resource. The discussion will further illuminate how Brand's experimental observations paved the way for a nuanced understanding of thermal reduction processes and reaction kinetics. Let us journey into this transformative moment in scientific history, exploring elaborate experimental designs and analyzing data in a manner that bridges classical alchemy with modern, rigorous chemistry, all while appreciating the unexpected beauty of discovery hidden within everyday materials. Born in uncertain circumstances around 1630, Hennig Brand emerged from an era rife with conflict and transformation. Though records of his birth remain obscure and his early life shrouded in mystery, intriguing fragments of history paint the portrait of a man caught between noble aspiration and humble beginnings. By some accounts, Brand was of modest lineage, possibly apprenticed as a glassmaker, a trade that demanded precision and attention to detail. His participation in the tumultuous 30 Years' War, serving as a junior officer, provided him with experiences steeped in discipline and resourcefulness, qualities that would later imbue his alchemical experiments with an unexpected rigor. After the demise of his first wife, whose considerable dowry financed his initial forays into alchemy, Brand embarked upon a financial and scientific reinvention. His subsequent marriage to Margaretha, a wealthy widow, not only restored his fiscal stability, but also permitted him to pursue his obsessive experiments without the immediate pressures of survival. In an era where the line between mysticism and emerging scientific inquiry was blurred, Brand dedicated himself to the study of alchemy with almost religious fervor. He meticulously cataloged his experiments, drawing upon an extensive body of alchemical literature spanning multiple regions and languages. His professional endeavors, underscored by the practical lessons gleaned from glassmaking and the disciplined command cultivated in military service, contributed significantly to an experimental culture poised on the brink of modern chemistry. His life and work exemplify the transition from arcane pursuits to systematic empirical investigation, setting the stage for a revolutionary breakthrough that would ultimately bring forth a substance glowing with an almost mystical quality. A discovery that transcends its humble origins to signal a new era in chemical science. Throughout the 17th century, the pursuit of the philosopher's stone captivated the minds of intellectuals and mavericks alike. For centuries, alchemists had labored under the belief that a mystical ingredient existed which could transmute base metals into noble ones, typically gold. Hennig Brand was no exception to this zealous pursuit. His laboratory experiments were driven by both esoteric ambitions and the promise of unlocking secrets of matter. His work was marked by a scrupulous approach to experimental design, drawing upon his technical background as a glassmaker which afforded him both the skill and innovation to manipulate high-temperature furnaces and delicate retorts with precision. Brand's approach to alchemy was both methodical and imaginative, as he explored the chemical potentials inherent in everyday human waste. Urine, a substance abundant and rich in inorganic phosphates, became the focus of his investigations. In a series of complex experiments, Brand endeavored to distill gold-like qualities from what modern scientists would now recognize as a repository of chemical precursors. His procedure involved letting urine stand to develop a pungent odor and allow preliminary chemical changes before boiling it down into a thick concentrate. This pre-treatment, steeped in both tradition and necessity, enabled the removal of water and the concentration of underlying phosphate salts. Subsequently, Brand subjected this syrupy residue to prolonged, intense heat within a sophisticated furnace setup. As the temperature rose, red fumes began to emanate from the heated mixture, a phenomenon that signaled the onset of a series of chemical transformations. The red fumes, coupled with the observation of a liquid that spontaneously ignited upon exposure to air, provided the first evidence that a more intriguing reaction was unfolding. Brand meticulously recorded the gradual emergence of luminous vapors, leading to the eventual collection of a glowing substance he later identified as phosphorus. Through a combination of persistent experimentation and careful observation, Brand managed to harness a process that essentially reduced phosphate ions to elemental phosphorus by way of carbon-mediated oxygen abstraction. Behind this reaction lay the fundamental principles of redox chemistry, where the carbon present in organic residues acted as a powerful reducing agent, stripping oxygen atoms away from phosphate ions. Despite the crude conditions of his workshop, Brand maintained an empirical record of temperatures, durations, and material quantities, revealing a surprisingly quantitative approach that prefigured modern scientific research methods. The meticulous nature of his experiment, characterized by strategic pre-treatment of urine and precise thermal control, illustrates a blend of intuitive craftsmanship with emerging analytical rigor. Although his experiments were aimed at discovering the philosopher's stone, the underlying chemical process offered a different kind of allure, a window into the hidden interactions governing matter and energy. His documented process provided early insights into reaction kinetics and thermodynamic thresholds, cementing his place as a pioneer whose methodical record-keeping and technical insight continue to inform and inspire. At the heart of Hennig Brand's experimental odyssey lay a serendipitous discovery that would alter the course of chemical history: the isolation of phosphorus. The breakthrough occurred in 1669 during an experiment intended to yield the philosopher's stone. Under controlled yet precarious conditions, Brand heated a concentrated urine residue in a specially designed furnace. As the retort reached an incandescent red, radiant fumes filled the apparatus, and a volatile, self-igniting liquid began to condense. This substance, which glowed with a pale, ethereal light both in liquid and solid forms, was ultimately identified as white phosphorus. Analyzing the reaction at a molecular level reveals a fascinating chemical interplay. Urine, though mundane in appearance, is rich in phosphate ions, PO43-TeUs, predominantly present in the form of microcosmic salt. These inorganic salts, when subjected to high temperatures, undergo a reduction reaction in the presence of an organic carbon source contained within the urine itself. The reaction can be succinctly understood through the equation PO43 plus 5C, P plus 5CO. Here, carbon serves as the reducing agent, abstracting oxygen atoms from the phosphate ion and liberating elemental phosphorus along with the byproduct carbon monoxide. Brand's apparatus was ingeniously simple, yet effective. By heating the urine concentrate in a retort and then channeling the resulting fumes through a cooling system, typically involving cold water, he enabled the condensation and isolation of phosphorus. The physical properties of phosphorus played a critical role in its identification. Notably, phosphorus remains in a liquid state up to approximately 280 degrees Celsius and condenses into the white phosphorus allotrope at temperatures below 44 degrees Celsius when sufficiently pure. Such thermodynamic behavior, though challenging to control, was deftly exploited by Brand, despite the limitations of 17th-century technology. Further scrutiny of Brand's procedure indicates that a significant portion of the phosphate present was inadvertently discarded. The experimental protocol involved the removal of a saline residue, which modern analyses suggest was rich in the same phosphate ions that could yield additional phosphorus if fully processed. In hindsight, the quantity of phosphorus that Brand obtained was a mere fraction of the potential yield. Historical records indicate that approximately 1,500 US gallons, 5,700 liters of urine produced around 120 grams of phosphorus. Calculations based on contemporary concentrations reveal that 1 liter of adult urine contains about 1.4 grams of phosphorus salts, translating to an eventual recovery rate of roughly 0.11 grams of pure white phosphorus per liter. Brand's discovery also extended into a realm that marries art with science. The luminous, almost mystical glow of phosphorus evoked strong aesthetic and symbolic interpretations among alchemists. Its steady luminescence, independent of external light sources, imbued the substance with qualities that both defied and complemented the contemporary understanding of life force in matter. Such artistic reactions testified to the transformative impact of empirical observation amid an era steeped in symbolic traditions. Modern chemists appreciate Brand's work not solely for its historical novelty, but also for its foundational contributions to high-temperature inorganic synthesis and redox chemistry. The reduction of phosphates via carbon under high thermal conditions bears a conceptual resemblance to modern methods deploying coke in electric furnaces for phosphorus extraction from mined ores. In essence, Brand's blend of empirical insight, technical innovation, and experimental rigor set the stage for subsequent advances in both theoretical and applied chemistry, marking a critical juncture in the transition from mystical alchemy to systematic science. Brand's serendipitous discovery of phosphorus resonated far beyond the confines of his modest laboratory. The immediate impact was a surge of fascination among his contemporaries. Eminent figures such as Johann Kunkel in Sweden and Robert Boyle in England soon replicated his findings, validating both the reproducibility and the profound potential of his reaction. Boyle's assistant, Ambrose Godfrey Hankwitz, ultimately commercialized phosphorus manufacture starting around 1707, signifying the critical shift from arcane experimental pursuits to an established industrial process. The discovery played a pivotal role in catalyzing the gradual transformation of alchemy into modern, systematic science. Phosphorus' unique chemical and physical properties, particularly its luminescence and high reactivity, offered a tangible bridge between mystical tradition and the emerging empirical methodologies of early chemistry. Its extraction process, underscored by stoichiometric principles and governed by kinetic constraints, provided one of the earliest quantifiable examples of redox chemistry in action. The meticulous documentation of thermodynamic thresholds and reaction kinetics in Brand's work prefigured modern industrial chemical engineering practices, laying a robust framework for subsequent technological innovations. In retrospect, the legacy of Hennig Brand lies not solely in the substance he isolated, but in his pioneering approach to experimental chemistry. His method, characterized by creativity, precise control of reaction parameters, and an analytical mindset, serves as an archetype for contemporary synthetic chemists. Modern applications of phosphorus span diverse fields, from semiconductor technology and biochemistry to the development of high-energy materials, underscoring the transformative impact of its discovery on both scientific research and industrial processes. The narrative of Brand's discovery stands as a testament to the unpredictable nature of scientific advancement. It reminds us that curiosity coupled with technical rigor, even when applied to seemingly mundane materials such as urine, can yield revolutionary breakthroughs. This exploration into the origins, methodology, and enduring legacy of phosphorus encapsulates a remarkable journey of innovation. A journey that continues to inspire experts to seek new insights at the intersection of art, serendipity, and systematic science.